So just to review what we did in the last video really quickly, I've already worked it all out, but here is a manager of a fast food restaurant, and he is seeing that the proportion of customers who has to wait at least 2 minutes was 63% of his customers. So he was not pleased. He wants to reduce this proportion. He doesn't want his customers waiting so long. So he's going to take a random sample of 30 drive-through times and then test it to see if it has actually decreased. Okay. To do this, he is placing an additional employee there, so he's going to pay them an extra salary to try to make this happen. All right, so when we run our test, our null hypothesis is we're going to assume that it has not changed. It is still 63%, but we're going to try to prove that after we've added this additional employee, we have decreased that wait time. So now we're going to have less than 63% of our customers waiting more than 2 minutes. So I checked my condition. They stated in the problem that it was random. Success failure, I had a sample size of 30 multiplied by the 52% p hat that I got in my particular sample. Remember that your calculator will not use decimals for this value, so we're just going to round it up to 16 people. And then if I subtract that 16 from the sample size of 30, that'll give me the number of failures. The number of people that did have to wait more than 2 minutes is 14. Since both of those are greater than or equal to 10, we have met the second condition. And then our third condition of 10%, when I multiply my sample size by 100, it equals 300. I'm sorry, multiply it by 10, it equals 300. And I think that is less than the population. I think I have more than 300 customers. Okay. All right, so I'm going to run a 1 proportion z-test at a null hypothesis of 63%. The sample that we got was 16 out of 30 were decreasing that time, and we're testing it against an alternative hypothesis that we chose less than for. And what I come up with is a p-value of 0.14, which is greater than the alpha level I was testing at, which was 0.05. So I'm going to fail to reject the null hypothesis, which means there is no evidence that the proportion of drive-through customers who have to wait is more than 2 minutes. We do not think that that has decreased. It has stayed the same. Okay, so okay, forgot where I was. I had to pause there for a second. I think I finished this part. So now what we have to do is look at, all right, we've run this test. We've done it at an alpha level of 0.05. So what I can say right now is I am 95% confident in my findings because I tested at a 0.05 level. Then 0.95 is my confidence. That's the other part of 100%. So because I am only 95% confident that this is correct, there is a chance that I have made some errors with this testing, or particularly one type of error. So there are 2 types of errors that you can make in a test. Number 1 is called a type 1 error. The second one is actually called a type 2 error. And this little picture kind of helps you think about how to determine that, even though this part is wrong. That is supposed to be that an innocent person is set free here. Okay, so what happens is in a jury trial, let's say that I am looking at a null hypothesis, and when we're talking about a jury trial, we always assume innocence. So my null hypothesis is supposed to be that this person is innocent. I'm going to assume that right out the gate. But what I'm trying to prove is that this person is guilty. And I'm going to draw a separate curve for this. I'm going to draw it a little bit to the right of the first curve, because what I'm going to try to do is gather more and more evidence against this person, and if I can gather that evidence, then I can determine them guilty. Now, there is some sort of mark, some sort of line. And we'll just say that this is going to be the line. This is how much evidence I have to have against this person in order to say that they are guilty. So if I get this much evidence, then I'm going to go with that result. But this little part of the curve up here, whatever's left after that, since this curve does not end, this is called a type 1 error. This is associated with the innocent person. However, if I get this much evidence, I'm going to say that they're guilty. So the first mistake that I could make, that type 1, would be taking this innocent person and putting them in jail. That's a mistake. Okay. If I don't get enough evidence, then I'm going to say they are not guilty and I'm going to set them free. Okay. Now, on the flip side of that, we have what we're trying to prove, the alternative hypothesis, and we have a guilty person here. So if I have enough evidence to say that they're guilty and they are actually a guilty person and we send them to jail, then that is not an error. That is what we want to do. That's actually called power for your test. However, we could also make a mistake that way, which is on the opposite side of the red line from where type 2 was. But this right here would also be an error. This is called a type 2 error. So in this particular situation, we're talking about the guilty person, but on this part of the curve, we haven't gotten enough evidence to cross over that line to say that they're guilty. So for a type 2 error, we're taking this guilty person and we are setting them free. So on your curve, this little light green space is where we're taking that guilty person and setting them free, which is a type 2 error. And the red space here is part of the innocent curve, but we have enough evidence to say that they're guilty. So this is the innocent person going to jail, which is a type 1 error. Now, you can't make both errors at one time. It just depends on what conclusion you come up with in your problem. So for that fast food example, here's what your two errors would look like. So for a type 1 error, type 1 can only be made if I have rejected the null hypothesis. So in that fast food example, to reject the null hypothesis would mean that I do have evidence that the proportion has decreased, the proportion of drivers that are waiting longer than 2 minutes. So I say that it has increased, so my error would actually be that it actually has not decreased. And anytime we make an error or anytime we make a mistake, we really need to evaluate what the consequences of that mistake are going to be. So if I look at the consequences for this, if I say that it has decreased, then I think this employee has actually made a difference when in fact they have not. So this company is going to keep paying an employee that really did not help. So the company is going to be wasting money. Okay. Now a type 2 error can only be made if your final conclusion to the test was to fail to reject the null hypothesis. So what you said is, I do not have evidence. Let me try that again. I do not have evidence of a decrease in the proportion, when in my error there actually was a decrease. Okay, so if I make this error, then the consequence of that action is I'm saying it did not decrease, it actually had. So I'm going to think this employee hasn't really helped at all. So I'm going to fire an employee that was actually making things better for my company. Okay. Now, in every single test that you do, you kind of want to think about which error is going to be the worst for me to make. And there's never really a clear answer on that because errors are never good. In my opinion, it would be worse to fire an employee that was making my business better. Because, well, actually, type 1 may be worse, I think, because you're going to keep paying this employee thinking he's helping, where if you fired him, you could try something different that would also make it better. So maybe type 1 in this situation would be worse, but as long as you can justify your thinking and which one you choose, it really doesn't matter which way you go with this. Now, for this particular example, in my test, I failed to reject the null hypothesis. So the only real error I could have made in this is a type 2 error. Okay, so there is a possibility that I may fire an employee that was making my company better. So when you weigh these, there are some things that you can do to adjust your test to make sure that the error you don't want to make has a lower probability. So back to these curves. If we look at a null hypothesis curve, let's say the top curve here is my null hypothesis, and I'm trying to prove an alternative that is less than. In this case, that's why the curve is to the left of the null hypothesis, because we're proving a less than. Then my alpha is going to be in the tail of the first curve. So this little tail on the left, because this is a less than alternative, this is going to be considered alpha, and it's equal to whatever you want to make it. If you wanted to do an alpha level of 0.08 and have a 92% confidence in your final answer, you could certainly set it that way. Now, for this one, if 8, and this represents what the proportion was to begin with, and this represents what proportion you actually got out of your sample to see how different they are. But wherever alpha is, that is your type 1 error. That is the probability of a type 1 error. The side of the curve on the opposite side of that line in your alternative hypothesis curve, this is the probability of your type 2 error, which isn't always easy to calculate. You don't really need to calculate it. But what you do need to look at is, okay, let's say I determine a type 1 error is going to be the worst possible error for my test. So I can adjust the alpha level to change. If I want to lower the probability that I make that error, I can make this section smaller up here. I could move that line to the left and say that type 1 error is now going to be much smaller. So maybe now I'm going to test at a alpha level of 0.02 instead to make this area smaller. But what happens when I decrease the probability of a type 1 error, I am increasing the probability of a type 2 error, which is okay if you think type 2 error is really not going to make that much of a difference in your problem. Okay. Same idea. If you decide type 2 error is going to be the worst type of error that you could make, then you want to decrease the type 2 error. So I could take this line and make my type 2 error smaller. So maybe I want to make sure that this area is the one that's really small. But in that case, that's going to increase my type 1. So we may want to increase alpha to 0.10 or 0.20 or whatever you want to do, okay? Although if we use an alpha of 0.20, it's probably not very convincing for you to just be 80% sure of your result. I would do at least a 90% confidence level, but you can adjust to make those changes in your problem. Okay, so I'll run through one more example with this. We won't go through the whole test, but we have a company manufacturing computer chips, and they find that 8% of all the chips manufactured are defective. So this is kind of what we know from the very beginning of the problem. Management is concerned that employee inattention is partially responsible for that high defect rate. So in an effort to decrease the percentage of defective chips, they decide to offer incentives to employees who have lower defect rates on their shifts. So the incentive program is instituted for a month, and if it's successful, the company will continue paying these employees with that incentive. So my null hypothesis is going to assume that things are the same from the very get-go. The percent of defective chips started out at 0.08 or 8%. But what we want to try to prove in our in our alternative hypothesis is that proportion has now decreased. It is now less than 0.8. So we can run the test. If we make a type 1 error, then what impact would that have on the company? So in order to make a type 1, remember we have to reject the null hypothesis in order for this to happen. So I would say that I have evidence that the proportion of defective chips has decreased. Okay, so the error that I could have made then when I say that is that the proportion has actually not decreased. Okay, so the consequence of making this error would be, okay, it's decreased. I'm going to keep paying employees this extra incentive when they really haven't made a change. Okay. Now, to make a type 2 error, whatever this test runs, to make a type 2 error, I would have to fail to reject the null hypothesis in my final answer. So I would say there is no evidence. I would say there is no evidence of a decrease in this proportion. And then my error would be that it actually had decreased. Okay, so the consequence of this action, if I say that it hasn't decreased, but it actually had, then I'm going to stop paying the employees and risk the chance of it actually increasing again. Okay, so I'm going to make a decision before I even run this test what I think is going to be the worst error. And I think for me, I would say that a type 1 error is going to be the worst type of error because I'm going to be paying money to these employees when they're not even really doing anything extra. So I'm going to want to decrease this as much as I possibly can. And I'm probably going to set an alpha level real low so that that type 1 error does not occur. All right, so I'm probably going to be like a 0.01 alpha level and do it at a 99% confidence level. So check that out before you ever run your test. Now, based on the data they collected during the program, management found that a 95% confidence interval for the percentage of defective chips was 0.05 to 0.07. So what conclusions should management reach about the new incentive program? Well, even without running a test, if I do an interval, then this is what I am expecting out of that true proportion. It should be somewhere between 5% and 7%. So because it was 8% to start out with, which is not in my interval, it's a little higher than my interval, then I would say that the proportion has decreased to somewhere between 0.05 and 0.07. And the conclusion that I would make to say that it has decreased is the reject the null hypothesis. I could see that just from the confidence interval without running a test. Okay, so think about those things when you're setting up the design of your test and what you actually want to report out.